Lesson 10.6, making inferences from factored derivatives. So these are all going to be multiple choice, just like I have here. Number 1 says, given the function f prime of x, and here it is factored out, what conclusion can be drawn directly from the sign chart of the given function about the graph of f on the interval x is less than -2? So the first thing I would want to do is make a sign chart for this factored function, which we know it doesn't have any kind of domain restriction, so this will go from -infinity to +infinity, and then it's really easy to pick out the zeros. So right here the 2 is nothing, but this would be x equals -2, and this would be x equals +6. And remember, the multiplicities can help us go a little faster. Put them in order least to greatest, so I'll have -2, 6. Let's start with plugging in 7 for x. That would be positive, positive times positive. And then looking at the multiplicity of the factor x minus 6, since it's an even number, it won't cross through, it will stay the same sign. And then looking at the multiplicity for the factor x plus 2, it's odd, so it will switch signs across -2. Okay, and then they want to know about the interval x is less than -2. So we're talking about the interval here. Okay, it's very important to figure out what they gave you. They gave us f prime of x, and they want us to know what's happening to the original function f. And so what this tells us is that the slopes of f were going down, they were decreasing. That's the only thing that we know, is that f must have been decreasing when x values were less than -2. All right, number 2, we're given another f prime function, and we're asked to draw a conclusion about graph of f when x is a specific value. So sometimes they ask you about intervals, sometimes they ask you at specific values. Let's make another sign chart. It might even help to put that this is the f prime sign chart. We're going to get zeros at 0, -4, and +4. If I plug in a 5, that would be positive, positive, positive. Looking at the multiplicity in the factor x minus 4, it's just a multiplicity of 1, that's odd, so it would change signs. Looking at how I get the 0, that was from this monomial here that has an odd multiplicity, so that would be crossing through again. And then looking at x plus 4, that is just to the first power, so it would cross through. And they want us to know what's happening when x is exactly -4. So what's happening, since this is the slopes of my original graph, so I'm asked to find about the original, I'm decreasing, then I'm increasing, then I'm decreasing, then I'm increasing. So this right here would create a relative min. If they would have asked me at x equals 0, that would have created a relative max. So think about what slopes are doing. They're decreasing, increasing, that creates a relative min. So those two types are the easiest for my brain to comprehend. Then it gets a little bit trickier. You got to think about it a little bit more. Number 3 says, given the function f double prime of x, what conclusion can be drawn when f prime is x is 7. But let's just do the same thing we're doing and make a sign chart. But now we are dealing with f double prime, not f prime. Zeros are calculated the same way. So that would be at 7, 2, and -2. If I plugged in 8, that would be positive, 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 but times this negative here would make that negative. If I plug, or at 7, if I look at multiplicity, that's to the first power, so that would cross through. At x minus 2, that's an even multiplicity, so it would bounce and be the same sign. And then -2 is a multiplicity of 2, so it would bounce again. So when x is 7, here's the thing. If this would have asked about graph of f, this would tell us concavity and where points of inflection are. If this would have asked about f prime, it would have been asking about mins and maxes. But because it's asking about itself, is what makes this one weird. Oh my goodness, I can't spell. It's asking about itself. So we don't have to do anything with slope. This is simply saying if this were just a normal function and I'm increasing, or I'm not even increasing, actually, I'm just positive. So that's like a function that's positive for this whole time. So I don't know what it's doing, but I know it's in the positive y values. And then at 7, it's going to go in the negatives or below. So here, this would be a 0. Okay, because it was asking about itself. I really don't even care that it was asking about or saying about the second derivative. I'm simply asking about a graph of itself. These values would be the zeros, and these values are whether it was positive or it was negative. And I'll come back to that here in just a minute. I've tried to organize my thoughts in a little table for you. Number 4, given the function f prime of x, what conclusion can be drawn about f double prime? This is one that you can't even do. Every time so far, we've either asked something about itself or one behind it. And what I mean by that is I think of f, then f prime, f double prime as being levels. This is like a level 1, then I up a level, then I up a level. You can take the second derivative and use that to know something about f prime or f. You could take f prime and know about itself or f, but you can't use something to tell about something a level up or 2 levels up from that. So I can never take f prime and know something about f double prime. It only works knowing about itself or backwards. Okay, so this is going to be none of the above every single time you see that we want to know something that's a level up or a derivative higher than the original. It's just not possible. Okay, while I'm on it, so here's this little post-it note. If you want to pause and write this down, you can. Let's see if it even makes sense to you like it does to me. If I have a normal function f, think about what a normal function is. Just forget all the derivative stuff that we've learned. Just back to algebra when you graph a function. Just graph a function. All we know is when it's positive for an interval, that means the graph is above the x-axis, or when it's negative. So that's when we have an interval question. If they ask us at a specific point, that means it's a 0 on the graph. It's a root or an x-intercept, or maybe it's nothing. If our function bounces at a point, it goes from positive y's back to positive y's because it doesn't go into the negatives. So those are your options of choices. Then when I level up and I do f prime, slope of a function tells me whether something's increasing or decreasing. It tells me what the slope is doing about this guy. Okay, so your options for an interval are increasing or decreasing. If it's at a point type of question, when we're talking about slopes, it could be a relative min or a relative max, because we're talking about where slope either goes from increasing to decreasing or decreasing to increasing. Or it could be that there's just a horizontal tangent line, but there's no actual relative min or max. That could be an option. Like when we have something where maybe it's doesn't change signs, where it's decreasing and then decreasing some more. And then f double prime is what tells us concavity only about the original function. So concavity is like a 2-level up step. Concavity only comes from f double prime when wanting to know about the original function f. It does not tell us concavity about f prime. And so if it's an interval question, those are your 2 options. If we do our sign chart and there's a sign change at that point, that means that's an inflection point, or it could be nothing. So we could do a sign chart and there's no change, that they were both positive. It means it's concave up and concave up, but it's not a point of inflection. It's kind of one of those where it goes like boop, boop, you know, kind of thing. My drawing's not very good. Okay, so hopefully that helps a little bit. There's 2 more problems I want to do with that in mind. So now we've got an F double prime, and we're asked about F prime. Let's make a sign chart. We're going to have a 0, -4, -6, and 5. If I plug in 6, everything would be positive. At 5, my multiplicity is odd, so it'd cross. At 0, my multiplicity is odd, it would cross. At -4, my multiplicity is odd. And at -6, it's even. And they want to know on the interval when x is greater than 5. So on my little chart that I made, I can't simply look here at second derivative and say, oh, it's concave up, because it's not asking about f. This only goes with f. I'm basically just saying what's one level below it. So what I do is I now look at f prime compared to how f was. I just want like 2 compared to the one before it. And so this just tells me that f prime must have been increasing because it's positive. And then number 6, we've got f double prime given, and they want to know about f. So we'll have at 0, 8, -7, -4. If I plug in 9, everything will be positive. At 8, it'll cross. At 0, it'll cross. At -4, it'll cross. At -7, it'll cross. When x is -7. So because we are 2 levels away from f double prime to f, that is now going to be talking about concavity. But with a specific point, it could be an inflection point or not. It is because I'm going from concave up to concave down. So there is going to be a point of inflection right there. If they would have been the same sign, it would have been none of the above. So hopefully my little chart helps you make sense of this.